Today, we're going to be talking about Angry Birds and kinematic physics. Let's jump right into it. Well, in physical realism in video games, there are games that are excellent, and there are games that are merely good. Excellent games include Doodle Jumps and Geometry Dash, while games that are merely good include Angry Birds and Super Mario Bros. Today, we're going to be analyzing Angry Birds. Now, the hypothesis is that the middle three birds in height in Angry Birds, which is the yellow bird, the green bird, and the red bird, will be approximately 5 meters tall in height, that the birds are going a constant downward acceleration, like gravity. So any object under gravity will receive a constant downward acceleration, which is to say that no matter where they are on the Earth, gravity will always act on them in a downward direction. And that also, in a realistically and biologically correct version of Angry Birds, the magnitude of gravity will be about 10 times larger than in the original game, compared to the birds. Now, this hypothesis was incorrect. The heights of the birds were approximately half a meter tall. And also, the constant downward acceleration simply was non-existent. I'll get into that. And also, the magnitude of gravity, ranged from 0.8 to 5 in a realistic Angry Birds game. I'll get into that, and was nowhere near 10. Now, and I'll give you a summary of the abstract right here. So, this study aims to understand the real-world dimensions of the Angry Birds universe, and also dissect how it could be made more realistic. Now, we have to analyze all the videos of Angry Birds frame by frame. That's to say, we break the video down into individual photographs, and then we dissect from there. Now, the hypothesis, as I mentioned earlier, is wrong on all counts. Now, detail my specific methods later on. Now, the conditions for doing this problem is that the birds are in free fall motion, and gravity is 9.8 meters per second squared. Data collection methods. Well, today we're going to have to go through something called the ticker tape timer. The ticker tape timer is a device that punches a hole in a piece of paper every 0.02 seconds, itself remaining stationary while the paper moves. Let's see it in action first and then explain it. You'll notice on the right, the dots are very dense, and on the left, the dots are very loose and far apart. This is because the close dots are slow and the far dots are fast. Given that a hole is punched every 0.02 seconds, if the paper moved a far distance in those 0.02 seconds, then the holes would be farther apart and vice versa. So on the left, it was moving faster. On the right, it was moving slower. Now, keep this figure in mind, 0.02 seconds per dot. We can't actually use a ticker tape timer because we're measuring something virtual. So I got the next best thing. Angry Birds happen to draw dots behind them as they go along, and they go by 0.0525 seconds per dot. I used an app called Filmora to analyze the video. By splicing the video into individual frames, I started recording when the bird started drawing the dots and ended recording when the bird stopped drawing dots, and found the ratio between dots and time. There was 0.0525 seconds passed per dot and about 19.05 dots per second. Now, this is going to be important later on. Now, notice how this says free fall motion. Free fall motion is when an object is falling with no other influence on them aside from gravity. This is going to be important because gravity is the only force we're going to have to really analyze here. So this simplifies our calculations by a lot. Now, since I previously got the ratio between time and dots drawn, I can conclude that 0.74 seconds have elapsed from the start of the fall towards the end of the fall, where the yellow bird is right now. And putting that into kinematics formula, and assuming g is 9.81 meters per second squared, which is the Earth's gravity, we plug it in and we get that the height it has fallen is 2.7 meters. Using proportion, we find the bird is 0.45 meters tall, and here's a 1.7 meters human for reference. So this would be about how big a bird would look next to you, give or take, depending on how tall you are. Now these are the birds in proportion, and these are the data showing how tall the birds are in actual statistics. This is a human for reference, and these are the birds compared to their actual species heights. I went online, found out which species the birds were based on, and got their actual statistics to compare to the birds in game. And here's gravity if the game was more realistic. So you'll notice that for every bird, the in-game version is always bigger except for the white bird and black bird. Assuming the bird sizes on screen remain constant, a more realistic Angry Birds game would have greater gravity, it appears, except for the white bird and the black bird, in which it would appear that gravity is smaller. This is because the actual sizes of the birds have changed. For every single bird, they would have shrunk except for the white bird and the black bird. Now, why is Angry Birds slightly unrealistic? Well, on the left, it's a PHET physics simulator, and it draws the dots at about the same rate the Angry Birds game does. Now, at the top, it's very dense, because it's supposed to be decelerating, and it would reach a zero and it has to accelerate again. However, in the Angry Birds game, it only follows the arc without actually changing the speed. This means that the PHET physics simulator is far more realistic, given that at the top, the dots are a lot denser. This is similar to what I described previously as the ticker tape timer. Conclusion. Findings were that the hypothesis was incorrect. The size of the birds were a lot smaller than their predicted sizes. The gravity-like acceleration simply does not exist. It was substituted by the change in the direction of velocity. And, furthermore, assuming the birds were their biological sizes, it was predicted that the gravity would be about 10 times larger than before. However, this range is from 0.8 to 5, so that's also wrong. So the hypothesis, in conclusion, was wrong on all counts. These are the works I've cited, and I would like to thank you, the judges, for taking your time to listen. Have a very nice day, judges.